right. I think we're ready to get going. Who's excited to hear about C# 10? Yay! I'll see you in 2 years. I'm just kidding. So we're going to talk about C# 8 and beyond. I've been here a few times talking about the future of C# and the features that are coming to the language. Unfortunately, they've scratched a few of the features that I've talked about in the past, so we'll talk about a few of them again. Hopefully they'll make it into the language the next time. I've traveled all the way from Gothenburg, and it took longer than flying to New York, so I hope you all like that I'm here. I love being back here. It's my third time. All right, so my name is Filip Ekberg, and if I can get my clicker working. You can ping me on Twitter if you have any questions afterwards, or just throw something at me. Please don't throw my own book at me. That's just insulting. So C#. There's happened so many things to C# over the past few years. Ever since they started rewriting the compilers with the Roslyn project, we've seen a tremendous amount of features being added to the C# language. We've had things like string interpolations, we have pattern matching, and a lot of more things that just makes it easier for us to write applications that are more readable and hopefully more maintainable for the future. It also invites more people from different paradigms, like F# developers, to participate in C# projects. Because now we can bring in more functional principles into the language. So over the years, we've had all these amazing features added to the language. And most recently, when they announced the compilers being open source, and they brought all these feature discussions onto GitHub, that means that we as developers or people that just love the language can participate in these discussions. So they have this feature set page on GitHub where they list all the features that they're intending to add to the language. And some of them are marked as this is coming into this language. They might not get into C# 8, but they will come into hopefully C# 9 or 10 or who knows. And what's also interesting here is that they allow people to contribute to the language. So anyone in here can build features that they like into the language, and hopefully that'll get merged into the compilers. So I think that's pretty cool. And then on another page on GitHub, on the C# language page, they list all the champions they want to get into the language. We have things like read-only members for struct. So who's excited about that? I think more people are excited about records and improvements to pattern matching rather than some of these small features. But since it's open source, a lot of people can contribute to these discussions and make sure that this gets into the language whenever they want to. As long as we can get hands on the compiler from the community, that means that we can get more features into the language, and we can get an even better programming language than we already have. If you have really sharp eyes, I don't know if you can see that, but at the top here it says that the 8.0 candidate is due to be released on January 1st, 2080. I don't think I'm going to be doing C# by then. Or maybe, if we're good enough developers, we might just stick to C# and we'll be the most paid consultants in the industries by then. So according to this here, it's 2% done. But in all honesty, what's going to happen here is that with Visual Studio 2019, which is hopefully just around the corner, we'll get a few of these features added to the IDE. So in the next few months, we'll potentially see previews of the Visual Studio 2019 IDE, and that'll come with .NET Core 3.0 as well as with C# 8. So Mads had an announcement a few days ago where he talked about adding this to the previews of the new Visual Studio version. So we'll be able to try out all these amazing features they're adding to C# 8, which is pretty great. So enough about that. Let's talk about what's actually in C# 8. So last year I was here talking about what's happening with C#. I talked about all the features that they're adding to C# 7. Things like pattern matching and tuples and deconstructors. And I'll have to show a few of them again just really quickly because they're making some improvements to those features in C# 8. They're adding something they're calling recursive patterns and ranges and nullable reference types. And a few of these requires us to understand these basic principles. And a few of these demos I can show you in Visual Studio. And the rest of them I have to show you in slides because they don't compile in Visual Studio. And frankly, I didn't have time to build the support into the compilers myself. So let's head into Visual Studio and just have a look at a few of these features. So the first one we're going to just quickly look at is tuples from C# 7. What we can see here is I have a method here called getPoint. And you'll see here that there's no type returned here. There's no concrete type. I'm not defining a new class that's returned here. I'm simply returning 2 values from this method here. I could even say that I want to return a third one and add that as a return for this method. This here internally creates a tuple for us that we can then later on use when we call this method. So we can see here when we call this method called getPoint, we can declare this to a local variable called point, and then point here has an integer x and an integer y. What's happening here is that it's taking those 2 parameters that are passed back from getPoint, and it deconstructs that into those 2 x and y variables that I have here. What's super confusing is if I rename the first one here to y and the second one to x, and you'll have all kinds of interesting bugs in your application. All right? So the other option, which is probably better, is to don't declare a local variable that you call point, for instance. You can use another version of deconstruction to say, well, I just want to create these 2 local variables. I want x1 and y1 here. Or even better, I don't want to specify the actual type that's returned. I can say var x2 and y2, and it just deconstructs that into those local properties, local variables. So that's super simple. That's tuples and deconstruction. Everyone with me so far? Perfect. So let's jump on to pattern matching. So pattern matching is a way for us to match on certain patterns. For instance, I have a shape here, which is an abstract class, and then I have a triangle and a rectangle, whom both inherit from this abstract type. Now, imagine that in my application, I get something called triangle, or shape in this case, and I want to perform certain operations on that. But I don't want to worry about typecasting that myself. I just want to run my switch block here and say, well, when this shape here is either a triangle or a rectangle, I want to do certain things. So an easy way to do that in C#7 is to say when this is a triangle, so it matches that as a pattern, right? So it takes the shape and matches that to a triangle, and then it casts that itself to the triangle itself here. And then I can use all the properties that I have available in the methods, of course, on my type. So I don't have to worry about the typecasting myself. Now this is the first version of pattern matching, and if you're coming from other languages like Kotlin or Swift, pattern matching can be many more things and look a lot better than this. But bear with me, we're getting there. And then of course we have the rectangle here, it casts that properly as well, so we can do r.width, for instance, and r.height. So that's the cool features added to C#7 that we need to understand in order for us to jump on to C#8 and talk about the features that are added to the language now. So the first one is recursive patterns. Now, recursive patterns is a way for us to kind of do pattern matching on steroids. What we're doing here is that we can now use more patterns. First, we match on the triangle itself, and then we might have another pattern saying, well, if the triangle's one of the sides is this value, we get into that scope. If not, we get into another scope. So let me show you one example of that. Here I instantiate one of my triangles. I set one of the sides to 10, then one of the other sides to 10, and then the last one to 20. And then I'm going to compute something on the shape here. And if we expand this here, you'll see that this looks a little bit different from the one that we had in C#7. So now we've introduced something called a switch expression as well, which is also a new feature in C#8, where we're saying, I want to perform the switch on this shape here. Each line here is an expression. So we can say, when this thing here is a triangle, and when both the A and B sides are not equal, I want to return that particular string there. And then what I'm doing on the other line here is I'm saying, well, when this is a triangle and C is set to 30, I'm going to capture this local T here, which is the triangle or the shape that's passed into my method. And then I can use the properties on that T here in that particular scope. So I could do T.A or T.B or T.C, right? So if that's not enough, what we're also seeing here on the third one here, it's an example of first matching the pattern on the type itself, which is the triangle, and then we're using deconstruction to match the out parameters that we get from our deconstructor. And to understand that, we need to look at the type for the triangle. So what you'll see here is that on the triangle, I've implemented a deconstruct. method here, which gives us the A, B, C, and as well as a point. And what happens in my switch expression is that I'm saying, well, I require it to have A, B, C, as well as the point, which you can see here. I'm saying I need A, B, and C, as well as I don't care about the X on the point, but I care about the Y. So this is a bit confusing. But what happens is that if I were to run this as it is now, we have only A, B, and C set. You'll see here that if I run the application, hopefully this compiles. So what I've done here as well is that I've introduced some preview versions of the compilers. So you can go into GitHub and you can compile Roslyn yourself and run that in your own project, which is kind of nifty. So now it's saying not sure. Don't worry about the next line. It says not sure at the top. That's because it's hitting this last line here, which is the default for the switch case, or the default case for the switch. So why is it hitting that and not this one here, at the third one here? That's because I have not initialized a point on my triangle. So if I do that, all of a sudden, it will know that this one here at the end is not null anymore. And it can now capture this variable y here. So if I run it again, it's going to say A, B, C, and Y, which is this one here. And if I change the C to 30, you'll see that it's going to say found a match. C is 30. That means that we now got to the second case here. So you can see it does them in order. So the first one it finds, it matches on that, and that's the scope that you're going to get into. And of course, if I change this B here to 20 and run it again, it's going to say A is not equal to B. So that's pretty convenient. That's a great way for us to kind of expand on the pattern matching that we've used in C#7. Now, another example of this is that, let's say that I have the famous person class. I have an employee and a student. The student has a property called graduated. Now, I want to find all the students, let's say in a collection, I want to find all the students that have not graduated. What I can do is that I can say, well, first of all, I'm just creating this person here who's graduated, it's myself. And then I'm saying, well, if the person is a student and graduated is set to false, then what I want to do is that I want to capture the name of that student in a new local variable, which I can then use in this scope down here. Right? So I can use the name property here or the name variable here. And if that's not the case, I can say, well, if it's a person, if the person is a student, I'm going to capture the student as an S here, which means that we get the student, so I can ask if it's graduated and get the name here. Then you can see when I run this here, it's going to say, well, great, Filip has graduated. And I can set this to false here, and you'll see that it hits the other one. Right, so that's pretty nifty. That's a great addition to the pattern matching coming in C#8. So the next one is ranges. Now, this example here also involves a few things added to C#7. Ranges is a way for us to work with collections of data. If you're coming from Python or other languages where you can say, give me a subset of data, and do that with a really nice annotation in the language, or a nice way to do that in the language, you'll kind of feel that you're familiar. So what I do here is that the first line here, I declare a collection of data. I'm using span of t and stack alloc, which were both introduced in the previous version as well of C#. The span of t allows us to point to a collection of data without copying that data over. So I can do a lot of interesting operations which are really memory efficient without copying over all the data that I have in my collection. So in this case here, I can say, well, I want to grab a subset. Maybe I want to grab number 5 to number 9. Without copying the array over, but I still want that in a new container. I could say, well, how about we slice the data and give me a new range, or give me a new span of t for this given range that I've declared here. So I'm saying, well, give me the 5th index towards the second to last element. Right? So this would give me index 5, which is number 6, and then give me 1 from the end, which is 9. I could also say, well, give me the last element. So if I run this here, don't worry about the last 9 there, that's the next example. But here we can see that it gives us 6 to 10. And if I change this to 2, for instance, it'll give us 6 to 8. Right? What happens if I do this? Haven't actually tried that. So that doesn't work. That's good. Because it wouldn't make any sense to ask for that number, right? So we can't ask to start at the 5th and then go backwards. That wouldn't make any sense. So another one that they're adding, so we get these ranges, and I'm doing a lot of magic to get this to work in my environment here, but this is going to be released in Visual Studio 2019, hopefully. I don't make any promises if they cut any features now. I've been doing talks about C# and the features adding to the next version for a long time, and they always cut something out. So please don't be sad if they do. So one other thing that they're doing is that they're adding indices, or a way for us to specify an index. So you've already seen the result here, but since we're here, we're saying give me a range, start at 5, and give me the second to last element. Which element would you think that this one here gives us? Well, I would imagine that if we do this, it would start at the end and give us 1 element back, but that's not the case. So this here is going to give us the 9. Maybe they're going to change that to the final version. We'll see. So what we're doing here is that we're specifying an index using this nice pattern, and we can run that, and we see that we get the 9th element. So no more, we don't need to use link anymore. We don't need to do length -1. We can do this nice indice instead. So there's one more example that I can show you from C#8, and that's the Nullable Reference Types. So imagine a world where we didn't introduce nulls in C#. That would be great. So many applications would work a lot better. I can promise we would have different problems, but people like to complain that nulls are the problems to bad design. So what I've done here is that I've introduced a preview version of the compilers. Don't worry about this thing here at the top that just makes the non-nullable types available in my application. So what I can do now, you see this question mark here, and you probably recall us being able to do this on value types. So we can say that we have a nullable integer or that we have a nullable double, but saying that we have a nullable string doesn't make any sense in C#7 because they're nullable by default. But now in C#8, we want to make sure that nulls don't occur anymore. So by default, everything's going to be non-nullable. So in this case here, you wouldn't be able to, well, you would be able to right now, but with a configuration, you could say that this is going to introduce a compiler error, for instance. But you'll see here that now the constructor here complains and says, well, you're not initializing name here, and that's supposed to be a non-nullable property. So the way to fix that is to say, well, name is equal to name, and then we would inject that into the constructor, or get that into the constructor, right? And then no longer have any errors here. But if we start doing this for everything in old applications, then we change the contract for everyone that's using our application. That's not the best approach, right? So that's why it doesn't generate compiler errors by default. So if we don't do that, and we still say that, well, name can be null, that's totally fine. So what do we do now? Well, when we use this here, I have a method called print here, and it's supposed to print the length of the person's name. Now you'll see here that there's some squigglies here telling us that, well, there's a problem here, and you have a potential null reference exception coming your way here. So how do we solve that? Well, first of all, we could make sure that the string down here isn't nullable anymore. There's no promises. I can still pass null in here. There's just, for now, it's just like warnings in the IDE, but that's close enough to good. That's good enough for me right now. It can get better. But I don't want to do that. I still want to have this nullable. And if we are sure that this isn't going to be null, we can say, well, I'm pretty sure that I promise that this isn't going to be null, and the error's away. So we can use the bang here to say, well, this is certainly not going to be null in my application. And this is a short way to get null reference exceptions. So don't do that. We can also say, well, let's leave that there. And we can also say, well, person here can be null as well when we pass that into the method here. And maybe you can't see it, but there's a little squiggly under the P here. So then again, I can say, well, I promise that the null thing cannot be null. Doesn't make any sense. And one more thing that doesn't make any sense is that you can do this. It doesn't complain. They're probably going to fix that. They have more important things to do. So now what I can do here, let's remove null here, and these things are no longer necessary. You'll see that it also complains if I pass null into the method. But then again, I can promise that null isn't null, right? So that's funny. All right, so those are the features that I can show you in C# 8. And next we'll go over to the slides and have a look at all the other cool features that are hopefully coming to C# 8. So we had a look at the pattern matching and the improvements from C# 7 to C# 8. We saw these switch expressions and how we can do the recursive patterns, which will hopefully increase the productivity of us as developers. I've been doing Kotlin for the last year, and I'm doing these recursive patterns a lot. And I think it's a great addition to the language. So what else is being added to C#? Well, we're getting something called async streams. Asynchronous programming and the async APIs have been something that a lot of people started using lately, especially over the last few years. And being able to do asynchronous streams is really powerful. And you'll see here at the bottom of all my slides, I'll publish these later on, I've linked to all the language discussions on GitHub where they talk about these features. So if you want, you can read more on the examples, or you can participate in the discussions, and you can leave your vote if you like it, or you like it, a thumbs up. All right, so what async streams means is that it's a way for us to do asynchronous enumerables. So imagine that we are retrieving a collection of data, and each item is going to be passed to us in an asynchronous manner, right? So we don't have all the data available to us from the start. Now, what they potentially will introduce here is that we can now use the await keyword with our for each loop. So we just append the await keyword at the front of for each, and what it'll now will do is that it'll just await the next item in the queue, right? So this pretty much just compiles down to an example looking like this here. So if you had a look at the internals of how the enumerator works, there's just a while loop, and it awaits the move next method, and then gives you that item. And of course, it calls disposes async in the finally block. So that's a nice addition. And then they're changing the way that we can instantiate objects. So last year I talked about C# 7 being one of these things where they try to cut down on all the characters that we write because we have a certain amount of keystrokes, as Scott Hanselman says. So we want to make sure that we don't write too much on our keyboards. So what they do with this here is that instead of having to write triangle is equal to new triangle, we can now just write triangle is equal to new. And I bet that in C# 9, they're going to remove those two parentheses. That'll be a nice addition as well. Now, I don't know, but they probably won't because that invokes the constructor, right? So it makes sense to have that as a looking like a method call. And another pretty cool thing with this is that that's a simple example, but if we look at this dictionary initialization here, we're creating a dictionary of string where the key is a string, and then we have a list of integers. And then we're calling new here without specifying the type itself, and that just infers this entire thing here. It just knows which type to create. And then for each element that we create in the object initialization down here, it'll just know that this thing here is a new list of integers. And doing this in the current version of C#, there's just a lot of more code that you have to write. So this is just one of those things that makes it easier for us and less code, right? So removing all that boilerplate from the language is nice. One more thing to just cut down on the characters. Instead of having to write, in this case here, we have the deconstructor that says, well, I have this int age and in string name. Instead of saying default and default, you can just say, well, just default this to the tuple that we have here. Deconstruct that into those two variables. So the next one, how many of you in here have written your custom attributes? Quite a few, right? And how many of you have liked to do generic attributes? Look at that. That's great. A few of you like to do that. So previously, I've seen this pattern a lot. You have the constructor takes the type, and you don't have to do that anymore. So instead, when you create your custom attributes, you can now just use the generic keyword like you can with any other classes. It's just a nice thing to have in the language, right? Another thing that makes it easier for especially maybe library developers and people building debugging debugging tools is this color expression attribute. So what it does is, in this case here, we have this assert method coming from debug.assert, and the second parameter is decorated with color argument expression, where it points back to the condition passed to that method. Sounds very, very weird, but let's look at the example for that. So in this case here, I can only call debug.assert and pass my condition into this. But what this translates to is that it takes the condition itself and passes that as a second argument. And you don't have to do the overload yourself. So that's really nice if you're doing logging or using Log4Net or anything like that, right? And especially if you have these magic strings yourself in your application, like when you're doing refactoring, this will just make a lot more sense to not have to have the second parameter there. So the next feature is something that I hope that they're going to apply this thing for more stuff in the language. So they're doing an enhancement of the using blocks, where they're using a pattern-based approach to figure out if that class is suitable for a using block. Pretty much, in this case here, I have a class called resource with a method called dispose, which doesn't implement iDisposable, but I will be able to use this in a using block anyways. So it'll just figure out that there's a dispose method. It'll look that up using the dispose pattern. So if you think about this example here for a second, in Golang, if I'm not mistaken, any class can be passed into any method that has method that's in one of the interfaces that it takes as a parameter. So let's think about that for a second. That means that I could pass an instance of a class into any method as long as it has methods that correspond with the interface that that method takes. So it's using a pattern to understand, does this have the methods that I need to call? Now that would probably mean that they had to change the CLR and the runtime and do some changes to the languages and compilers as well. But I think I like where that is going with the language, or potentially could go. And since they're taking features from Golang and Kotlin and Swift anyway, so why not take that as well? Now speaking of interfaces, they're also making a change to interfaces where they're going to allow us to do default methods on interfaces. So imagine if you're a library developer and you release this first version of your interface. This is an iAuthentication interface where you just expose one method. Your users of this interface implements your method, and then all of a sudden you release a new version. And everyone's applications breaks because they haven't implemented that method. But you'll see here at the end that now this one here has a default implementation. I'm just using an expression here to say, well, the default implementation is that it's going to return a null user, or the default user. So that means that if there's any code in my application that, in this case here, says, well, I expect an iAuthentication and I call authenticate async, it'll just use this default implementation. So that's pretty cool. Now, one of the problems with this is that, well, what happens if we have two interfaces with default implementations and I inherit from those, then I kind of have multiple inheritance. Without the instance variables, of course. So there's not the same problems they would get in C++, but it's still the same idea, I guess. All right, so there's just a few more features in C#8, and then we're going to talk a little bit about features that they're going to add much further on, and maybe not at all. They're also adding null coalescing assignments, which is just a way for us to, again, cut down the characters. So instead of having to write x is equal to x, and if x is null, assign it to y, we can instead just say, well, just assign x to y if it's null. And they're doing the same with and the OR operators as well in future versions of C#. So there's a few more things. We talked about the switch expressions. They were going to relax the ordering of refs and partial modifiers, alternative interpolated verbatim strings, which means that you can, doesn't matter if you have the @ or the $sign first, and then stack alloc in as the contexts. So these are features that I didn't find as interesting as the other ones. So that kind of makes up for C#8. It's a lot of features added to the programming language to make it a little bit easier for us to build exciting applications. So now, after this version, they don't need to wait for a release of Visual Studio. They can just ship the compilers as they want, but they just want to make sure that the experience in the IDE is good enough and test it out. So coming further on in the future is, who knows what they're going to call this? I bet they're going to skip 9. Just call it C#X. That'll be cool. Everyone seems to do that. And then we'll have XL, XR, XS. Let's follow Apple. All right, so don't be sad if the features you like don't make the cut, because they're going to cut things out. They're going to make sure that not all of these features are implemented, because some of them are really hard to implement and make easy for developers to work with and not break backwards compatibility. So one of the things on the table is negated condition if statement. So we can do this today. We can say, well, we check if the shape is a triangle, and then we have the not operator first, but this isn't really readable. So how about we make it a little bit better and say, well, if shape is not a triangle, or we could say, well, if not shape is a triangle, which is probably as bad as the first one, or we could say unless shape is a triangle. I think they're still discussing which one is the best. I reckon they should go with this one. Would make sense. And then, of course, in a world where we don't want to have null reference exceptions in the applications, they're making improvements to async and await as well, to say, well, in this case here, we say, well, if task is null, just return null, otherwise await the task, and we'll return that value. Instead, we can say, well, await bang task, and that'll just make sure it doesn't break the application. So one of the features that I've been hoping to get since C#6 has been record types. And I've talked about record types so many times. They got added soon. It's a great feature. Imagine we have this class again, triangle shape. It has all these things. It's an immutable type. We can't change A, B, and C once we've created it. There's a lot more code that we would want to have in here, but this is kind of boilerplate code that anyone that builds larger applications write all the time. So how about we can make this a little bit more simple and say, well, I have this public class triangle of A, B, and C. It's a shape, and then just build a lot of boilerplate code for me. So what would that boilerplate code look like? Well, it would introduce all of these things in here. It makes sure that we have the constructor. It introduces the equality checks, which would make sure that if we compare two triangles, it doesn't only compare the references, it actually compares A, B, and C on both of the triangles, which makes a lot more sense. And then, of course, we have this method called with here, which will allow us to create a new instance of the triangle with new values. So since we want to move to a world where everything is immutable, just like strings, we can't change strings without creating a new string. In this case here, we would be able to say, well, give me a triangle with A set to some new value, right? And then we'd use all the other values from the current triangle. And then, of course, it introduces this deconstruct method here at the end, so that we can use this nicely with pattern matching as well. So hopefully they're going to add this soon. There are some issues with this, and it's hard to get around, I guess, especially when it comes to inheritance, from my understanding. So if you have two records, what's going to happen if one record inherits from another record? Yeah, so that's a tough one to solve. Could just not allow inheritance, but that doesn't make any sense either. So I'm not a language designer. I just like to spend time on GitHub. All right, so another one that they've introduced and changed and improved over the versions of C# is declaration expressions. So in this case here, we can, for instance, say, well, we have this while loop here, which is going to set the character to the next character each time. It's going to compare that to a few different characters. But wouldn't it be nicer if we could move this thing down here to the context where it makes sense? So this is kind of with the similar to how they do with the new the way out works. So you can just have the declaration expressions on one line. So it's the same here, essentially. And then another feature that they are looking at, these are all the champions that they have listed on GitHub. So these are probably up for a grab. So anyone in here that wants these into the language, you can just go ahead and start coding away on the compilers. It'll probably take a long time to get it in there. I started looking at one of these features and saw, it was this guy, he built, I think there was a new one, or I can't remember. And it took a long time for him to get it into the shape that they wanted, to follow the coding standards and all the guidelines and just make sure that everything works. But once it got in there, that's a nice achievement. So definitely worth it. So one thing they're adding is dictionary literals, which is just a way for us to, in a nice way, create dictionaries a little bit easier. I've got a feeling that C# is starting to look a little bit like Python, especially with ranges and these things, and I don't know. It's still nice. It's a way for us to write less code, especially for boilerplate stuff that we normally write. And they're also looking at adding type classes, which I'm not smart enough to explain. It's like prototypes in Swift, if anyone knows what that is. Read-only struct members, which I talked about. Params of span T. These are just like proposals from people. Like anyone can suggest proposals to the language. So these aren't set in stone that they're coming. Some of them will probably be scratched. Static local functions, and as I mentioned earlier, they're also adding and is equal or equal. It's a mouthful to say, but yeah, assignment operators. So looking at these features added to from C# 1 through C# 7.3, there's a lot of features added to the previous versions of C#. Everything from generics to the async and await keywords, to string interpolations, to pattern matching, all the null things, nullable value types. I think all of these things makes it easier for us to build applications that are pretty good and readable and maintainable for the future. So hopefully the changes that are coming to C# 8 through whichever version that they want to use next, hopefully they're going to be as good. Especially, I'm really excited for the null reference type and the improvements to pattern matching, because that's something that I use in other languages all the time, especially in Kotlin and Swift. And of course, records would be great to get to the language. All right, so if you have any questions, ping me on Twitter or shout out or come up afterwards. But other than that, thank you so much for listening to me. I'm Filip Ekberg. Please remember to vote on your way out. Thank you.